Hi everyone, I'm Manios from CERT and I will present an overview of the Social Graph Mining extension module of the HELIOS platform. The Social Graph Mining module aims to mine underlying preferences that drive user behavior. Essentially, this translates to utilizing social actions, such as forming relations or performing interactions, to form vector representations for each user. These representations reside in some latent space that is not necessarily explainable to humans, but can be used in machine learning prediction tasks. In its current form, the Social Graph Mining module uses these preferences to recommend who to interact with among social acquaintances. HELIOS is a decentralized platform. Therefore, the Social Graph Mining module is designed to work in a peer-to-peer communication setting. This means that each user's device runs a copy of the module, and this boots up potentially different types of preference mining algorithms. Although ideally all user devices would run these algorithms, the mining module can be disabled in individual devices without introducing errors. Their respective users are then treated as offline from a mining perspective. As a final remark, mining is context aware in that it may produce different predictions depending on the user's HELIOS context. Given that the Social Graph Mining module runs in devices, these should exchange parameters in order to converge to commonly accepted representations of users and their social neighbors. A parameter exchange scheme that suffices to set up the Social Graph Mining module is exchanging parameters at the same time social interactions occur, such as when messages are sent. This introduces only small overheads compared to continuously exchanging parameters. Furthermore, it takes advantage of communication channels that are already open to perform the interactions. This way, preference mining is not affected by users going offline. We now overview the parameter exchange protocol followed by the Social Graph Mining module. As a first step, when an interaction is sent to another user, certain parameters need to be sent along. These are used by the receiver to update their preference mining algorithms. Then, the receiver of the interaction returns new parameters to the sender, for example with the same timing as communication acknowledgement. Finally, the sender's preference mining algorithms are updated with the returned parameters. It is important to note that enforcing this communication scheme is currently left to the discretion of the developer using the HELIOS platform. From a code perspective, the Social Graph Mining module's functionality is provided through an abstract class called the SocialGraphMiner. This is extended by various types of miners. Miners use entities of the contextual ego network module to reference the same in-memory social graph node, edge, and interaction objects, or attach data to be saved on those objects. The contextual ego network is a core module of the HELIOS platform, and more details can be found in the corresponding tutorial. Classes extending the Social Graph Miner implement a recommend interactions method. This method returns a map from contextual ego network nodes to positive scores. Higher scores estimate how much the device's user wants to interact with the respective nodes. Finally, the Social Graph Miner provides two methods for organizing the previously outlined parameter exchanges. GetModelParameters is a method which returns a string representation of the parameters to send or return. NewInteractions is a method which notifies the interaction sender and receiver about the parameters of the other party. For now, it is important to remind that parameter exchanges are organized by the developer. In particular, these code snippets demonstrate the parameter exchange scheme followed by the Social Graph Mining module. First, when a new interaction occurs, the sender side retrieves an interaction object from the local contextual ego network using the respective module's methods. It then uses the getModelParameters method to obtain a string serialization of the parameters to send. As a second step, the receiver creates their own contextual ego network interaction object and calls the new interaction method with it. Additional arguments to that method are the sender's parameters string serialization and a receive enumeration label. Then, the receiver calls the getModelParameters method to obtain a string serialization of the parameters to send back. Finally, the sender gets the receiver's parameters and calls their own new interaction method. This uses the same interaction object as before and a receive reply enumeration label. Do note that different instances of the contextual ego network and the Social Graph Mining modules run on the sender and receiver. We now look at miners that extend the Social Graph Miner class. The first one is called Repeat and Reply Miner and recommends all their interactions based on their chronological order. Other heuristics can also be found in the Social Graph Mining module, but this one closely mimics who users currently place their attention to. The second is called GNN Miner and aims to discover drifts in user preferences. Effectively, this miner is preferred for recommending recurring interactions. In more detail, it implements a decentralized shallow graph neural network model. This model extracts and keeps track of underlying preferences that can reproduce past interactions. Then, it recommends interactions based on current preference similarity. For more details on these two miners, as well as experiments that corroborate their intended usage, please refer to the deliverable 4.3. The envisioned usage of the graph mining module's miners is to allow users to switch between them, depending on what kind of recommendations they are interested in. To do this in a way that retains parameter dissemination and hence not lose out on predictive capabilities from miners being inactive, the SocialGraphMiner module introduces the switchable miner class. Effectively, this class wraps multiple miners at once and aggregates their parameters to exchange. We recommend using a singleton instance of this class as a top-level abstraction of mining tasks, since it also checks and exchanges parameters only between compatible miners. As shown in the example code, the switchable miner class can be instantiated with a contextual Go network instance. Then, new miners can be registered through its createMiner method, which takes as input a reference name for the new miner and its class. The createMiner method instantiates a new miner object of the given class, assigns to it a name for future reference, and finally returns it. In the example code, a repeat and reply miner named repeat and a GNN miner named GNN are created. Furthermore, the GNN miner setDeniability method is called to introduce a certain degree of plausible deniability and differential privacy. For other ways of registering miners to switchable miner objects, as well as potential tweaks of the GNN miner, please refer to the module's Java doc. To change the currently active miner of the switchable miner class, its setActive method needs to be called. This method takes as input a name used during the createMiner operation. Changing the active miner only affects which miner is used for prediction, but all miner parameters keep being exchanged. This operation can be called at any time with no overhead and only switches which miner is used to recommend interactions. Recommendations by the active miner can be obtained by calling the switchable miner's recommend interaction method. For future directions in the SocialGraphMiner module's development, we plan to introduce more mining algorithms such as personalized PageRank or other graph signal processing filters. Furthermore, we plan to integrate the functionality of the communication module to introduce automatic parametering changes. This would allow faster deployment of the module by making its usage as simple as adding a listener to the contextual Go network. Finally, social graph mining can be combined with other machine learning extension modules either to improve their predictions or to use their outcome to improve recommendations. The social graph mining module is available in this GitHub repository. There, you can find Java documentation as well as integration instructions for Maven and Gradle via Jetpack. For example, integrating this module to an Android Studio project is as simple as adding Jetpack to the project dependencies as shown in this slide, and then adding the HELIOS module itself to the Android's module dependencies. This will also hierarchically add the contextual Go network module.